Okay, so we are on page 81, and we're kind of reviewing graphing, substitution, and elimination, just because we've done a lot of problems, and you really need to know why or when to use what type of problem. So your title is Solving Systems of Linear Equations, and your essential question is how do you know which method to use? So go ahead and make sure you have that written in your notebook on page 81. Okay. So, if you need to pause the video. So this is the graphing part, and it says when to use this method. And it says if both equations are in slope-intercept form, which is y equals mx plus b, and yours might have been cut off kind of like mine, so please go over that with your pencil. And also use slope-intercept form if a graph is readily available. That means if they give you a graph, they're most likely telling you that you need to use the graphing method, obviously. So let's go ahead and graph it. They're both in slope-intercept form, so it's easiest to do it this way. So my y-intercept is -4, so I go down 0, 1, 2, 3, 4. My slope is a +3, 1, 2, 3, rise over run, rise over run. And again, I didn't bring a ruler home, so I'm going to be using another foldable. Okay, so that's my first line. My second line, I'm going to do in another color. Y equals x plus 2, so I'm going up 1, 2. And I'm going up 1 over 1, up 1 over 1, up 1 over 1, because it's a positive slope. And I draw my line, and my point of intersection is my solution. So my point of intersection is 1, 2, 3, up, 1, 2, 3, 4, 5. So my point is +3, 5. Okay, so now I'm on the substitution method, the substitution method, and it says when to use this method if one or both equations is already solved for one of the variables. So if I look, the difference between here and here, both of these are solved for y, and only one of them is solved for y. So if one of the variables has a coefficient of 1 as well. So if we look, I can plug this amount to where y is, because y equals -2x plus 3. So I'm literally substituting values in. So I'm going to have -5x plus, and then I'm going to have -2x plus 3, because that's what my y equals -4. So from here, all I do is solve for my missing variable, which is an x. And I have -5x. I'm going to drop my parentheses because that plus, whenever I distribute, it's just going to keep it the same. Oops. So I have plus -2x plus 3 equals -4. Combine like terms on one side. -5x plus -2x, they're same sign, so I'm going to add. Plus 3 equals -4. I subtract 3 from both sides, and I get -7x equals -7, and then I get x equals +1. So from here, I plug it back into my equation to figure out what y equals, and I have y equals -2 times +1, because that's what x equals, plus 3. So y equals -2 plus 3, so y equals +1. So my solution is going to be x is 1 and y is 1. So 1, 1. Okay, so the last one I'm going over is elimination, and when to use this method. If both equations are written in standard form, that's when you use this method. So example 3, I have 15x plus 5y equals 35, and 2x minus 5y equals -1. So from here, they're both in standard form, and I'm just going to combine them because I already know that these two will cancel out by looking. So I have 17x And then I have positive 5y, negative 5y, which is going to make a plus 0y. And then I have 35 minus 1, which is going to equal 34. So this goes away because 0 times anything makes it go away. So now I divide by 17, and x equals 2. And from here, I plug it back in. I'm going to plug it into the equation with smaller numbers. So I'm going to have 2 times 2 minus 5 times y equals negative 1. 4 minus 5y equals negative 1. Negative 5y. I subtract by 4 because it's a positive, and when I do that, I get a negative 5. And so I have y equals positive 1. So my solution is 2, positive 1. And that is your entire video for today. Make sure that you glue this on page 81 and you do the worksheet that belongs with this page that we talked about.